Please ignore that picture. Okay. Ladies and gentlemen, thank you. If I can have my PPT up. Okay. I'm going to talk about a buzzword. Machine learning. How many of you think it is a buzzword? No? Just one. Thankful. So I'm going to talk about what's the latest, where are we going, and what kind of great things we expect to see in the security world as we move forward. Can I have the clicker, please? Can I have the clicker? Perfect. So we have seen, we have heard our colleagues talk about what we are doing nowadays. So you have also heard people talk about perimeter security has been around for a long time. It's not really working. So around 2005, before 2005, we were really talking about how do I protect myself by creating walls, right? 10 years down the line, we were talking about how do I take all of these data, create intelligence by creating a whole bunch of rules and making sure that I can understand how people are what people are doing, and if this doing is a bad sequence of steps, stop them. Right? So we were talking about security intelligence that really helps me understand how people are doing bad things. Is intelligence really helping us be there where we want to be? Of course, it is there. I mean, we are in a state of security, as Dr. Bell was also talking about in the morning. We're doing a lot of things. There is a state of security. But we also know there is a whole bunch of gaps that we have to work on. And identifying these gaps and being ready with these gaps is what is very important. The first gap, we've got all this intelligence, but are we really confident that this intelligence is going to deliver me what it is supposed to deliver? I have this huge bunch of data which is in front of me, but I'm really concerned about my attack. I'm not concerned about that 150 blacklisted IPs, but I'm really concerned about that one which might affect me. So that intelligence that we are gathering across so many different data points, how is it really applicable to me? And that is slowing things down. I can have bigger and bigger systems to do the number crunching faster, but that's really not going to stop that, bringing that gap down. So I have the gap in responding to a security incident. I have a gap in detecting a security incident. So there will be always a gap with the security. And then another buzzword, not a buzzword, we all fear this word, false positives. And pretty much everything out there, all security tools out there would tell you that there will always be false positives. We can have methods by which false positives can come down, but the reality is there will always be false positives. And these false positives are going to make it more and more difficult for us to prioritize and focus on things that are really important for us. Right? So the present day that we are, our human mind, the security analyst sitting out there, he has this gap. He has the gap of security intelligence. He has the gap in responding to an incident, and he has a gap in which he is spending most of his time trying to eliminate false positives. And that is true for pretty much all security frameworks that we have or deployments that we have. And that is where we need to start thinking, is there anything that we can do? And magic, we have it, right? Cognitive security. So here we are talking about how can this security system use the latest technologies to think like a human, but at a much, much, much faster way. Right? So if I can think and create, if I can sit on Google and talk about Bad Rabbit or read about Bad Rabbit, 5 minutes I'll get certain information. That information, is it useful for me? Maybe yes. If I take 5 days, I will learn more. I'll forget something. Now that is where this cognitive security or the technology that we are talking about really is focusing. If security can learn itself, adapt itself to what is important, and then reason it out that yes, this is important for me. And that is what I'm going to try and explain, how we are using technology to simulate what we want to see. So the topic of my talk was machine learning and how it fits into the security world, right? I hope the fonts are readable from back there, but here we're talking about a generic understanding of what this artificial intelligence, machine learning, data mining, big data, these are the words that build up this next gen of cognitive sciences. What we are saying is that the cognitive security is nothing but a system that would be using artificial intelligence technologies to make sure that the security systems are behaving like a human. He is able to recognize patterns like a human. And machine learning helps me to read that particular data and create patterns or reasons. It is able to read free-flowing blogs. It is able to read data that is written down by a journalist or a researcher. So there we are talking about not just the, the list of IP addresses or list of IOCs, but is the human intelligence that a threat researcher might be writing on his tweet. What machine learning can really do is take in these different forms of data points and push it into a particular pattern. And this pattern, looking into the pattern, machine learning will also help you reprocess this understanding and process it till it finds that yes, this is useful. I'm sure I have made my statements in cyclic order, but that's how really machine learning, or we learn as well. When you take in our intelligence, we revalidate that and validate it and validate it again till we think that yes, this makes sense. And that is what machine learning would be doing, using data mining technologies to pull in the relevant information from wherever it is and applying it to the patterns and understanding that is applicable for my organization. Now I'll give you the topic also says demonstrating certain use cases. So I'm going to talk about a certain use case, how machine learning can use that information which is out there and make it insightful enough for me to be actionable, right? How much of data your security analyst knows and how much of data about that security problem is there on the internet? Just for Bad Rabbit as an example. You have got 3 guys who is security experts, and there are 3 lakh security experts writing about Bad Rabbit on the net. And they've got inside there, they've got useful information out there, right? So the internet is full of data. There are research stuff which is being written, there are a whole bunch of data. Now can I use these machine learning, artificial intelligence technologies to go ahead and read that data out there? So if you look into this picture, it's pretty much like an iceberg. What we really know is only so much, and so much of data is there out there as documents, as blogs, as so many different ways. So what we built up is a technology, is a platform which will actually go ahead and read that data from all the different security providers, researchers, enthusiasts, and create that knowledge base, that reason, that pattern, that links around that different data points, so that when I need it, it can give back that data in the form of a graph, which I can then start analyzing. Pretty much all these things are the, these are the various data points which are relevant to me and how they are linked to each other. Now this activity of bringing in the relevant information becomes a matter of a minute rather than those days that we would normally be spending on. Right? I would like to again reiterate what it is really about. So the first use case that I'm going to, I'm presenting here is when I want to know more about a zero-day data. I do not know. I just have few facts about that zero-day attack that has happened in my organization, and I want to research it more. Traditional way is you go to the net and read. The new way, or the cognitive way of doing it, is you go to a system which has already read that data and is a super knowledge base which knows the linkages between the black IPs, blacklisted IPs and blacklisted IOCs and patterns and processes which end up here. And that data comes back to your security analyst in a matter of minutes. And all those insights can then be zeroed down. So you cut down the skills gap or the speed gap that was there in the traditional way of things and make it work better. I would have loved to take a feedback here, but I'll go forward with my next use case that we are using artificial intelligence, machine learning technologies in a practical world problem. The next practical world problem, and we have heard about this behavioral analytics, and most of the behavioral analytics today works on advanced statistical analysis. I know I've done certain activities, and here's the statistical probabilities. The next activity that I'll be doing is this. So normal statistics is what helps me. Now, where do I use machine learning to enhance the statistical data points and make sure that I am able to simulate what a human would normally be doing rather than what a machine would do one after the other? So statistical data is more of prescriptive thing, but in this case I do know that humans do different things. They do ad hoc things. And if I go ahead and start taking a deviation from every normal deviation, I will not be humans, right? At the end of the day, being a human, I will have difference in patterns. And if I have to pick those up, data points up, and just match it to a statistical analysis, I end up with a huge amount of false positives. And that is where machine learning comes into the aid by understanding that this is how humans would normally behave, and this particular human would normally behave, and then come up with those data points as to which is actually a deviation. So I make it learn, I do the statistical analysis, match it up, and they say most probably this is a malicious activity. And then we can add up more machine learning algorithms. For example, in this particular case, we could use the clustering algorithms to see what is, what seems to be a group behavior which is leading to a malicious activity. It's not just one individual, but a set of individuals who are doing things. So that's where it helps me understand. Cognitive, as I told you earlier, cognitive really simulates a human behavior, and that is where it becomes very useful when I apply to what is normal user behavior and what is deviation from normal behavior, and hence it is worth looking more into. Right? So the deployment that we have done, which is now actually working as an example, okay, again the fonts are not that great. Here we're talking about how many users we are monitoring, how many data points we are looking for that particular behavior. Are you looking into his network activity? Are we looking at his file activity? Are we looking at his idle activity? There's so many data points that we could feed into the system to create those patterns and repatternize to make sure that it is a human pattern that I come into, that I'm working against. So those were the two snapshots that I wanted to talk about in terms of a demo of how cognitive security is really helping us zero down on things which are most important. And in this case, if you see, there is absolutely no false positive. The data out there is what I'm giving you back. The deviation is what I'm giving you back. Now, the deviation, analysis of that deviation is something that you'll be doing next. So there is no false positive really in this particular activity. And there are other areas or other use cases where using this. We're talking about how do I identify malware activity. How do I really know it's a zero-day activity? We heard Kapil saying earlier, 0 day is a known activity, right? So 0 day unknown, known. Okay. But what is really 0 day, right? So we talk about insider threat detection. We're talking about behavioral analytics, malware analytics, and a whole bunch of some use cases where we are using this pattern capabilities and this natural language processing capabilities merged into creating patterns or behaviors which tells me this is good and tells me this is something worth investigating next. Right? Just a snapshot of all the different algorithms that we have been using. This is public data. You could have a look somewhere. So we're talking about insider threat. We're using some and malicious traffic, botnet domains, network activity, and so on and so forth. That's my last slide. Thank you so much. I think we'll take questions. We are around here. We can. I'm happy to discuss more about all of these. Do we have one question? Time for one question?
Just one question.
No, we're just taking one question.
So, can we have a mic there, please?
Hello.
Hi, this is Devojyoti Basu from NSHM, Knowledge Campus. I would rather ask you a practical question which we faced around a couple of days back. We received an email from our ISP stating that there is a bot attack in our system, and we have got a good antivirus and a good UTM in place, but somehow both these antivirus as well as UTM could not detect the bot, and it infiltrated in our network and probably did something, and that's why the ISP notified us through an email. So this is something which is beyond our control. So how to tackle with this kind of a situation as far as this machine learning is concerned, if it has got any correlation with this?
First of all, I wouldn't agree that it is not under our control. It is definitely under our control. If I have to believe Kapil talking about earlier, 0 days are known things, so which means that if it is known today, which means it is under control. Now, there are technologies, there are processes, there are awareness gaps which lets us end up in this particular problem. Can machine learning help me with this? Yes. Because when the malware is coming and doing something on my system, it is doing something different. We are not just monitoring it. We are not just able to take this data up of difference and analyze it. Today's world, the problem really gap is that we are not looking into enough number of data sets and analyzing the data sets and creating patterns or intelligence out of it or insights out of it. With these kind of technologies, you would be able to look into more number of data in a real-time manner. For example, when a malware hits, something is changing on the system, the process is changing, the file is changing, some, some network activity is happening which never happened earlier. And if I start looking into all of these and I do deep data mining of all of these data, analyze it with machine learning capabilities, I'm pretty sure this is what we intend to do. If I look back into that particular slide, the slide's gone anyway. One of the domains in which we were talking about is malware detection. So yes, definitely malware machine learning capabilities would help us. So here, malware family detection and malware detection are few of the things where we are using machine learning capabilities to identify them. In fact, the entire of endpoint threat detection domain is machine learning driven. So there is a whole domain around that which people are working, and at least there are, I would say, 30 to 40 odd vendors who are actively pursuing that particular field.
Any specific guideline that you would like to for this kind of activities, for detection of this kind of activities?
Guidelines means you need to be ready to adopt these technologies. This is the future. If I'm not ready with my basics, as earlier people had been talking about, I need to take those minimum basic hygiene steps before I can even think of utilizing machine learning capabilities. So what guideline? The guideline would be follow the best practices, get your system to a certain level which is easily done with the kind of tools which are there within the security domain today, and then be able to take the next step into adopting the future generation technologies.
Right. Thank you.
Yeah. Okay, thank you so much.
Thank you so much, sir. Can I request